Hello, IB math students. Okay, looking at this assignment on its learning under functions and exam type questions on chapter 3, section D. So I opened the file in preview, the PDF file in preview, so that I can actually write on it by doing some annotation. First part of the question, on separate paper, draw the graph of this polynomial on these coordinates. Okay, so I'm going to use the calculator to help me with that. I have the key press history down here on the lower right hand screen, so you can see what buttons I'm pushing to graph the function. Again, f of x is y, and in this case we're going to say it's y1, and I want a negative 1 over 3. Use the fraction trick here. Arrow to the right, x cubed. Arrow to the right again. Plus fraction trick, 5 over 3. X squared minus x minus 3. So this is our function in y1. We're given some specific values for x and y to graph it on, negative 3 to 6. So I go to the window, start the x values at negative 3, go up to 6. Again, the increment, the x scale is 1. Negative 10 to 10 is what they asked for y. And then I can go to the graph and get an idea of what it looks like. Okay, typical curvature for a cubic. All right, so we're asked to graph this on separate paper. So they specify the scale here. We have to be very careful to follow the instructions. Use an x scale of 2 centimeters to represent 1 unit on the x-axis and 1 centimeter for 1 unit on the y-axis. All right, so I have my iPad here to help me draw this. Again, 2 centimeters on the x-axis, 1 centimeter on the y-axis. And actually we were down here, I think. That's a black line I hope I'm drawing. Maybe not. Let's try red. Okay, I can see that line. All right, so that's going to be my y-axis, and my x-axis is going to go like this. And again, this is kind of like 1/2 centimeter graph paper that you might have in your notebook. For the exam, you'll have millimeter graph paper, but that's way too many lines for me to use on my iPad. So each centimeter is 2 lines. So the x scale is going to look something like this every 4 lines. I think I'm supposed to start at negative 3. I didn't go far enough down. And then the y scale is every centimeter. Okay, so that's two lines for y equals 1, 2, 3, etc. And I had to get all the way up to 10. So obviously your graph is going to be bigger than mine. So I would use the coordinates that are given in the table on the calculator to graph this function. So I go second table, and now I have the coordinates to plot from -3 up to +6 for x. Okay, so -3, 24 is down below my axis. Again, -2 is about 8 1/3. Again, up top. -1, I can finally plot, on my graph here. I should use a different color. Try black again. It's supposed to be black. All right, and then that's -1, 0, -3. I didn't continue my scale down here to -3. Next point down here. Then 1 is -8/3, which is like 2 2/3. 2, -1, 3, 0, and then I'm supposed to continue out to the other side. So your graph, I'm only doing part of the graph. You're going to have a bigger graph than mine. Looks something like this. Plotting each point at one interval. Okay, find the value of f of -1. That's right in our table. F of -1 is 0. And again, I could plug it into the formula there, do substitution, and do it by hand. But the value is right there on my calculator. I might as well just do it that way. Tools, annotate here. Sorry, f of -1 is 0. Okay, write down the y-intercept of the graph of f of x. The y-intercept is where x is equal to 0, so that's just going to be -3. Write down the coordinates of the local minimum point of the graph of f. Okay, so again, I would use the graph to find this minimum here. Okay, clear my key press history here so you can see more clearly how to do it. All right, so I'm on the graph and I want to find the minimum here. So I go to second, calc, minimum. And then I want the left bound to the left of that minimum. So I'm scrolling to the left. I'm going to hit enter. Then I'm going to scroll to the right of the minimum for the right bound. Enter. And then if I hit enter again, it will find the minimum in between those 2 points. Okay, now this minimum is x equals 1/3, because again, the calculator is rounding. And then 3 significant figures, I have to put in -3.16. So again, I could give it the 3 significant figures and just do, oops, as we said, okay, so I need to write down the coordinates of that local minimum. I rounded to 3 significant figures. I could have put in 1/3 there. This is the X and Y coordinates. Okay, find the coordinates of the local maximum of the graph of X. Again, looking at our graph or the graph that I drew, I can see that the local maximum is probably right here at X equals 3. But I would like to confirm that using the calculator. Again, I'm going to clear my key press history here and do a second calc, trace calc. And I want to find the maximum. I can shortcut to 4. And I want to do left and right bounds around that maximum. So I'm going to go left bound before the maximum, right bound after the maximum, and then confirm that maximum is, with the third entry, 3. And then this is a very small number. This is 10 to the minus 12. So that's like 0. Okay, so the maximum is 3, 0. If you looked at our table before, that's what we had for a local maximum there. Three comma 0 for the local maximum. All right, so the range and domain of this function, again, turns out, again, if we look at our table, it turns out that there are no errors. There are no places that we are dividing by 0. There are no places that we're taking the square root of a negative number. Those are our 2 restrictions on domain. So if the domain is unrestricted, what are the y values that are resulting from that domain? Again, we can see the graph here goes up and up and up and up. We don't know how far up it goes, but it's out of our window here. And it goes down and down and down and down. So we're going to just assume that the domain and the range are all real numbers. So you can write that as an inequality. You can write it as X is a member of all real numbers. Either way. And the same for Y. The domain and range are unrestricted. So I don't know what I was doing here. I was going to write in domain colon D colon and then negative infinity up to positive infinity with X. Don't have the infinity key here on preview. So that's your domain and range, all real numbers.